Hello everyone, my name is Gennaro Notomista, and today I'll be presenting the work I've done together with Magnus Egerstedt on coverage control for wide traversing robots. First of all, why should one study coverage control for wide traversing robots? Well, wide traversing robots lend themselves to a large variety of applications such as environmental monitoring and agricultural robotic tasks. Some of the reasons of their success can be recognized in low energy requirements, the simplicity in the motion control that leads to small localization errors and virtual absence of navigation problems. A second question is why coverage control for wide traversing robots? Coverage control algorithms are used to spread robots over an environment. These can be employed, for example, to achieve sensor coverage in environmental monitoring applications or plantation monitoring in agricultural robotics applications. Nevertheless, wires introduce constraints to the motion of the robots that render the motion control problem interesting and challenging. Let's look more in detail at these challenges. Under coverage control, the robots spread out to cover an area. In the video, the area enclosed by the gray rectangle. What if there are wires in the environment and the robots are constrained to stay on them? There are several simple solutions that could be applied. The first one consists in projecting the unconstrained motion onto the wires where the robots are constrained to move. The problem is clearly a poor coverage quality. To improve coverage, the unconstrained motion could be projected onto the closest wire. However, this strategy will produce discontinuous motion of the robots. The proposed solution is then a continuous onto wires mapping. The motion of the unconstrained robots, depicted in gray in the video, is mapped onto the wires in such a way that the resultant motion of the constrained robots, represented in the video as colored robots, is continuous. The final coverage quality is the best achievable, since each robot ends up being in the point on the wires closest to the corresponding unconstrained robot. This algorithm has been implemented on real robots on the Robotarium, a remotely accessible swarm robotics testbed, as shown in the video. The wires have been projected down onto the surface area that had to be covered by small differential drive robots. I'm looking forward to discussing with you the described coverage control algorithm for wide traversing robots at the interactive session. Thank you very much.